Okay, Unit 4, classifying triangles. We're going to classify triangles by their angles and their sides. So, classifying triangles by angle. And we've been talking about this already plenty, and you already all know this. Acute angle, an acute triangle, all the angles are less than 90 degrees. So we've been talking about acute angles plenty. Now we're applying it to triangles. A right triangle has one right angle. Because if you think about it, there's no way to have two right angles in a triangle. It's not possible. There's no way to close and make it into a triangle if we have two 90-degree angles. Because think about it, 90 and 90 is 180, and a triangle only has 180 degrees. So where's the third angle going to fit in? It doesn't. And obtuse, kind of the same idea. You can only have one obtuse angle. Because if you have an obtuse angle here, and an obtuse angle here, there's no way to make a triangle out of that shape. So you can only have one obtuse, one right. And acute, they're all acute. Now, we also have equiangular, meaning equal angles. And that's when all of them are 60. It's actually called, we'll be referring to this later, a 60-60-60 triangle. So if you notice here, these pictures, obviously this is going to be a right triangle because we have the symbol right here. 35 and 18. Well, we got to figure out what this angle is. 35 and 18 is 53. 180 minus 53 is 127. So since this is 127 degrees, that makes this an obtuse triangle. Here, 68 and 55. That's 123. 180 minus 123 is 57. Which makes this acute because all of them are less than 90. Now we can also identify them by their sides. Scalene is when no sides are congruent. Isosceles is two sides, and equilateral, meaning equal, lateral means sides, means all three are congruent. And once again, we'll use our markings, our hash marks, to do that. So, classify as acute, equiangular, obtuse, or right. Well, right here, as soon as we have one over 90, that's obtuse. Exactly 90 is right. All three under 90, acute. And a 60-60-60, equiangular. Also acute. It's just a specific type of acute triangle. All right, so next, there is a very useful formula that we're going to use a lot, and you have used this in Algebra 1. It's the distance formula. And we use it to find the distance between 2 points. So all we're going to do here, it's very simple. You take your x number, 4, and I suggest you do this way. You don't have to. I always suggest you kind of do this first and have everything in the right place, especially when you're dealing with negative numbers. It leads to less confusion. So you have x of 4 and then x of negative 2. This is why you got to be careful here. And then y of 6 and y of 8. I said be careful because remember, when you do subtract a negative, it basically makes it plus. So what we have here is now the square root of 6 squared plus 6 minus 8 is negative 2 squared. Now please be careful. Remember, when you type negative 2 in the calculator and square it, it'll say negative 4. most likely, because it's doing order of operations. So you have two choices. Be smarter than the calculator, just remember a negative number squared is always positive, or just type in 2 squared, or use parentheses. So what that leads us to is 36 plus 4, and that's going to be the square root of 40. Now I will accept either that answer, or if you go to your calculator and do square root of 40, that is 6.32. So 6.3. We'll accept either answer there. Example 6. This, if you remember, is the distance formula. So what we're going to do is we're going to we could put this on the grid, we don't have to. So -3, -2, very hard to read, but this is -3, +2 is right here, that's x. And 2, comma 1 is y. And -2, -3 is z. Now we don't have to draw, all we have to do is do the distance formula from x to y, from y to z, and from x to z. So we just have to do this formula 3 times. It's a very simple formula. Distance equals the square root of x minus x. So I'm going to do xy first. -3 minus 2. Those are my x's. Squared. Plus 2 minus 1 squared. -3 minus 2 is -5 squared. Plus 2 minus 1 squared. So that's 25 plus 1. So that's the square root of 26. We don't need to get the decimal, that's fine. Now I'm going to do y to z. So distance equals the square root of 2 minus -2 squared plus 1 minus -3 squared. Well, this becomes plus, so that's 4 squared. This becomes plus 4 squared. So that's the square root of 16 plus 16, which is 32. And now I'm going to do xz. So -3 minus -2 squared plus 2 minus -3 squared. Well, that gives me, remember this becomes plus, -3 plus 2 is -1 squared plus 5 squared. So that becomes 1 plus 25, which is 26. So I have the square root of 26, square root of 26, and the square root of 32. So remember, this was xy, this was yz, and this was xz. So that means xy and xz are the same measurement. Which means this is an isosceles triangle. And there you go, that's it. All right, now we're going to do the same thing one more time. So KPL. So basically we need to find KP, PL, and KL. And so when I do this, I like to put my what I'm finding out there. So again, I do this. Then I put in my K, 5. And I put in my P, 3. My X. And now my Y's, or X is here, Y is here. Y of negative 3 and Y of 4. They go in the same order. So K, P, K, P. And I'm just going to crunch those numbers. So 5 minus 3 is 2, squared is 4. Negative 3 minus 4 is negative 7, squared is 49. So that's the square root of 53. So I type that in my calculator and I do the square root of 53. I get 7.28, so we're going to put 7.3. That's KP. Now we're going to do PL. And just repeat the same process. So I'm going to put my skeleton like so. I'm going to put P, there's my X, and negative 1 for my L. And then my Y's, P and L. And just crunch the numbers. So remember here, that's going to become plus 1. So 3 plus 1 is 4. 4 squared is 16. 4 minus 1 is 3. 3 squared is 9. That is 25, or simply just 5. So that's PL right there. PL is 5. And last, we're going to do KL. So again, put my parentheses. Put in K. Put in L. Now put in my Y's. K, L. And crunch the numbers. 5 plus 1 is 6. Squared is 36. Negative 3 minus 1 is negative 4. When you square that, you get positive 16. And that's going to be 36 plus 16 is 52. So the square root of 52 is about 7.2. So notice, close, but notice, square root of 52 is different than square root of 53. All right? So I'm going to come over here now and put my points. So remember, we had square root of 53. Well, the board's going to be not nice. We had square root of 53, which was 7.3. We had just simply 5. And we had square root of 52, which was 7.2. So let's go ahead and plot that. Put the points on. 5, negative 3. Right there. 3, 4. Right there. And negative 1, positive 1. Right there. And you should use a straight edge for this. Now, it looks like it could be scalene. It looks like the two sides are very similar. 5, negative 3, that's my K. This is my P. That's my L. And KP and KL look pretty close. But remember, this is 7.2, 7.3, and 5. So that is scalene. Okay, even though it's close, we call it scalene. And that's it.